Welcome back to the class on textile finishing. Till now, what we have learnt? We have learnt that there are non-formaldehyde based agents which are nitrogenous in nature, and these can be used for cross-linking. These include azidenyl compounds, isocyanates, pyridinium salts. So, all of them are non-formaldehyde, but have nitrogen as one of the elements. We have also learned that there are non-formaldehyde, non-nitrogenous compounds also, which can be used for cross-linking, such as a combination of glyxyl and glycol mixtures, polycarboxylic acids, acid chlorides, vinyl sulfones, and so on and so forth. Therefore, you have N-methylol based compounds, non-formaldehyde compounds, non-formaldehyde non-nitrogenous compounds, all of them can be used for cross-linking. It must be remembered that some of the agents may not be used by a pat dry cure process, that is, the pat dry cure process may not be suitable, and so they will have to be used in solutions. So, in some sense cross-linking in solutions or in wet state, that may have to be done. So, that is what it is, depends on what is the need, one can use these chemicals. Previous to that, we had learned what kind of catalyst etc. can be used. Today, we will discuss one important topic, and that is release of formaldehyde. Now, what should we do? What are we going to be talking about it? Let us see. So, the question that remains is, the formaldehyde is some type of environmental issues are there with the formaldehyde release, and so what should we do? Should we use zero formaldehyde based compounds, that formaldehyde free compounds, or we can use formaldehyde based compounds, but with a controlled release? What do you think? I mean, it is always good if you could use compounds which have nothing to do with the formaldehyde. So, obviously, there will not be any formaldehyde release. But there are very efficient compounds which are formaldehyde based compounds, which effectively do the cross-linking and are efficient wrinkle recovery agents. So, that kind of finish, should we completely discard all those compounds which have been very efficient, or can we do something about it? Let us see. This table we had discussed in earlier lecture also. What it says is, the international standard therefore are not talking about zero formaldehyde, but they are talking about limits, how much formaldehyde release, if at all, is allowed for a certain type of an application. For example, babies' garments obviously are more strict in these regulations, and therefore, for example, in this case is written less than 16 milligram per kg is the limit. But if you look at decorative material, the limit is 300 or less. So, we as an international body not talking about zero formaldehyde, but are talking about limit. If the release is within the limits, it is hopeful that it is not going to be very harmful, and so we should also look at the possibility of using already established cross-linking agents and look for methods with which the release of formaldehyde could be reduced. That could be a very wise angle to think about. Suppose then we decide that okay, we would like to see how we can reduce, control the formaldehyde release. All right. So, what would be our strategy? What can we do so that this happens less? So, let us say one of the thing which obviously people will talk about is selection of cross-linking agent. So, we are not talking about a cross-linking agent which has nothing to do with the formaldehyde, like formaldehyde free cross-linking agents. That of course would have no problem. If you can use them, there is no issue at all. But we are looking at the formaldehyde based cross-linking agents, which also some of them may be more resistant to hydrolysis. I am sure we are quite aware that DMDHEU is more resistant to hydrolysis compared to for example urea formaldehyde. Therefore, you have a possibility of selection. A DMPU may be more resistant to hydrolysis compared to, let us say, DMEU. And therefore, if we have a choice, we should be able to select certain cross-linking agents which otherwise are going to give less formaldehyde. So, that is one strategy which we can adopt. The second strategy which people have suggested is after wash. Now, technically speaking, this is not a very attractive proposition, but it is a very effective proposition, in the sense that when you finally finish a product, like you have made a wrinkle resistant fabric which has gone through padding, drying, curing process in a stentor, you may not like to wash it because it is already been done very nicely, and that becomes an issue. If there is a formaldehyde presence in the treated fabric, either as a free formaldehyde or otherwise, then it will get released during storage, during use, and so objectionable. Therefore, something must be done. So, if you do the after wash, then this so called free formaldehyde this definitely can be washed off, and then you can take care of the liquor in one way or the other, which is the wash liquor. All right. The question that remains is, well, whether it is attractive or not, we shall see. Other strategy could be using some type of scavengers, formaldehyde scavengers. Now, these scavengers obviously will pick up the formaldehyde if it is available and not let it be as free. So, it will become in some sense bound. So, these scavengers are chemical compounds which can be added to the bath. This is one option that one has. So, you have a cross-linking recipe with cross-linking agent and their catalyst and wetting agents and so on and so forth. Add some amount of formaldehyde scavengers in that bath, and so we hope certain amount of problem could be solved. After treatment with the scavengers, that means fabric has been finished and you are not satisfied with the release once you have tested it, then you may like to give an after treatment with scavengers. All right. So, these are some of the alternatives available which can be used as a good strategy to control the release of formaldehyde. So, as far as selection is concerned, we are sure that if you have a good agent which does not release too much formaldehyde is a good idea. Once done, let us look at the afterwash. As I mentioned a few minutes before, afterwash is not a very attractive proposition. Why? It is effective but not attractive. Why not attractive? Well, you have finished the fabric completely and now you want to wash it, that means the liquor again comes to picture, wash liquor, and then after that you have dry again. So, energy and water both are going to be consumed more. Who likes that? Nobody. And therefore, in a sense, whether we talk about economy, we talk about energy consumption, this cannot be considered as very attractive proposition. So, what do we do? Should we forget about it? But no, it is an effective process. And what is the effectiveness of this? That anything which is free formaldehyde this will be washed off surely. Of course, therefore, it becomes effective. So, anything which is free on the fabric will be washed off. If that happens, then obviously, we will be having less amount of formaldehyde to be released and we can be happy about it. Now, question that remains is, it is always possible that the formaldehyde which is not cross linked, but is bound. For example, the cross linking agent which has one such group which was supposed to have cross linked has not cross linked, while the other one end of this has, let us say, cross linked, covalently bonded, shall we say. So, this part is, this end of the cross linking agent has been covalently bonded, the other is free, could not for some reason react statistically. Can afterwash remove this bound formaldehyde? I am sure you would agree with simple wash, this bound formaldehyde is going to be difficult to be removed. Are you getting the point? So, afterwash can be effective to definitely remove free formaldehyde, but may not be effective in removing this bound formaldehyde, because this binding is also covalent. Is that right? So, there is some limitation, but we are quite sure that this bound formaldehyde release is a slow process which will depend on hydrolytic stability of this point, this area, this part of the cross linking agent. If it had actually cross linked, that if this particular thing had cellulose on both sides, let us say, reacted, then the hydrolytic stability is much more. So, release is much less. We are not saying 0, but much less compared to this part, which is a pendant hanging part. All right. So, release can be here during storage, during washing, during heating, and so on and so forth. Certainly nothing compared to a free formaldehyde, which will just evaporate and come into the vapor form. So, good amount of problem is solved, but not all. So, yes, free formaldehyde can be released. However, the bound formaldehyde can have some issue, right? The bound formaldehyde can have some problem. All right. So, we see what else can be done. So, we can now think of some other chemical agents which we are referring to as scavengers, formaldehyde scavengers. These scavengers can react with free formaldehyde if it is in solution. All right. They can also block unreacted methylol groups. So, thereby they will be able to add value, reduce the possibility of hydrolysis, not make it 0, but reduce. So, this is possible. So, they can be added to finishing agent or finishing solutions or finishing bath. That is how it can work. So, as we mentioned before also, you can use these scavengers in the padding bath or use them as an after treatment. Okay. So, scavengers can be used either in the pad bath itself, so that together with the cross linking agent, the scavengers also go to the drying and curing process and control by combining, by the free formaldehyde combining with the unreacted part or end of the cross linking agent. So, that is one possibility, but if we use in the bath, so they can definitely remove free formaldehyde, they bind with the free formaldehyde, but at the same time if they can bind with the methylol groups, then it will be difficult for the methylol group to cross link now. So, theoretically what we are saying is that they can definitely block, but at the same time it may reduce the cross linking efficiency. All right. So, what it means? You are compromising on the effectiveness of the cross linking itself, because something which could cross link with the cellulose, the hydroxyl group of cellulose, now has been bound by some other agent, which is going to happen because both of them are present together. So, this one becomes a limitation. Usefulness is there, but there is a limitation. As far as the formaldehyde release is concerned, you may be able to control it, but you may have to agree that there is going to be less cross linking, and therefore, crease recovery angles can drop, although formaldehyde release would be reduced. The other is an after treatment, and after treatment means what? After treatment means when you have already finished the fabric and now you want to control the presence of formaldehyde there by an after treatment with a scavenger. In this case, we are quite sure cross linking has already taken place. Whatever has not cross linked is anyway available and that could be bound. Anything which is free, there is a formaldehyde is there, it should be removed or blocked. So, theoretically, although this adds to the cost of production, no doubt, this will be the most effective way of reducing the formaldehyde. Good for the user. So, some suggestions which are there in terms of scavengers. These scavengers must be able to react. We have said some group called the nitrogenous. Look at this. You have an interesting compound called urea itself. Do you remember? We have a cross linking agent which is dimethylolurea. How was it produced? Obviously, it had a formaldehyde and urea. So, if there is a free formaldehyde or anything else that is available, theoretically urea can react with formaldehyde. Similarly, other ureas like DMEU, how was it produced? It was also produced by ethylene urea. And so, if you use this, the formaldehyde can again react with this. And of course, other than that, there are other compounds which have been suggested, which is one of the interesting compounds, the carbohydrazide, which is relatively more reactive and therefore, it can bind effectively, quickly, anything which is free formaldehyde and so on and so forth. And of course, ammonia or carbonates, bicarbonates of ammonia can also be used as scavengers. Okay. Let us look at these one by one. Urea and formaldehyde. So, let us see how was that possible. So, you have urea, this is urea, and if we add a formaldehyde, this will obviously give us a compound like this. You recognize this compound? Yes, this is the N-methylol group, right. So, it can further combine with formaldehyde and give you in effect another N-methylol group by reacting with the other molecule and you get so. If you look at this, do you recognize this? This compound is almost like the cross linking agent we were using earlier. But here the role is reversed. There we may have worked hard to make a cross-linking agent which can be reacted with cellulose. Now there is a free formaldehyde available anywhere, and it can react with the free formaldehyde to make a compound which then can be removed, washed off, or kept as it is. If you remember, these two types of groups can actually react with themselves, and self polymerization is something we talked about. For example, if you have a compound which has this N-methylol group because of the urea that we have added, let us say this was only NS2 in this end, but you have another agent of the similar type So, one can think of reaction in this area, and what you are likely to get is a link like this. All right. So, what is this? This is self condensation, all right, or a polycondensation. So, you have many such molecules and they will keep combining. So, this is self condensation reaction, and what kind of a group they will be forming? We are quite aware of this kind of a group, which is ether, all right. So, this ether linkage can be produced. Therefore, you could produce a bound formaldehyde based compound which is the N-methylol. You can produce polycondensed material which would also be bound by many formaldehyde units. Another possibility also is there if urea is available and a non-ether link which is, let us say, the methylene link can also be produced. How would you do that? For example, if you had the same compound which was partially formed, we have seen that same compound, and instead of this you have a simple urea which was also available. And then what can you form? You can form another compound which will look like this. So, this link is the methylene link which is a non-ether link. So, you can produce a ether link with polycondensation, you can produce a methylene link with a reaction with a free urea which is available along with this bound N-methylol group. So, this reaction will also be there, and of course, the formation of a dimethylol urea type of compound also is possible. So, in some sense the urea, if you add in the bath or as an after treatment, you will be able to bind free formaldehyde and also react with the bound formaldehyde to produce a different kind of a group, which will be relatively more stable to hydrolysis. That makes sense? Yeah. So, what is the conclusion? What is the conclusion? The conclusion is that the after treatment with urea is an effective process to control formaldehyde release. And what it means is the release levels can come down to such levels which may be acceptable for a particular use. So, depends on how much have you been able to reduce the release, application could be decided. It could be either babies, clothing or a decorative product, depends on how much have you been able to reduce. Similar to this, people have suggested use of acrylamides also in the bath or otherwise, where these can react with the formaldehyde, and by use of this, if we believe that during this whole process not only formaldehyde will be bound, but acrylamide can also become polyacrylamide, and if polyacrylamide is considered, then it is something which cannot be very easily washed off also, and formaldehyde would remain attached to this for a longer period, and theoretically we can also say the wash fastness could be better. But yes, there may be a risk in this case if polyacrylamide is there on the surface also, if it has not been washed again at some stage, the fabric may get a stiffer handle. Okay. You must remember one important thing is, when you have finished the fabric, you have packaged it and you are selling it, if the release takes place during this period, this is from a customer point of view is unacceptable. But it does not mean that the customer will never wash his fabric or a garment, right. If the first wash is controlled, before the first wash things are controlled, afterwards the release is not going to be very high, it is not going to be very high, and if they are bound also, then it will be much less. So, you should be able to control the release by the scavengers of this type. Urea definitely was useful, cheaper also. So, when we are talking about urea, you have ethylene urea also. You remember this ethylene urea we just talked about, it is also urea compound, but a cyclic urea, right. So, this cyclic urea is capable of reacting with formaldehyde and would produce what? Will produce a compound which we are quite familiar. What is this compound? Well, we call it DMEU. We already understood earlier that because of cyclic nature, the condensation will not be favored very much, polycondensation will not be favored very much, but binding with any formaldehyde group, binding with itself, it can react to with another urea compound or itself and make methylene group, it is possible, but at least it has been able to control some of the formaldehyde which may be present. So, this type of ureas have also been suggested as scavengers. The interesting compound which has also been experimented with is carbohydrazide. It looks almost like urea, but it's got more nitrogen and therefore is a much more reactive compound and can react with formaldehyde. I'll like for you to find out how the reaction takes place. I am sure you can do that exercise if you know how to do it with the how the urea reacts. If you know that, then obviously you will know how to write an equation which is with carbohydrazide, but it is an effective compound. Another application which has been tried, instead of calling it a scavenger, this is also sometimes known as neutralization of formaldehyde. And how does it happen? Well, if you use ammonia, so you have ammonium bicarbonate, ammonium carbonate, and if this is available, for example, formaldehyde in vapor form, can react with what? These carbonates and bicarbonates can release ammonia. If they release ammonia, what it means is that both are gases in the vapor form, vapor phase, an interesting reaction occurs with formaldehyde, which people call it as neutralization of formaldehyde. And what is this? So, formaldehyde 6 molecules react with 4 molecules of ammonia, which is being released during this, let us say, curing, post curing process, and you get this interesting compound which has a structure like this. And this is interesting in the sense that this is a drug, this is a drug, an antibiotic drug, which is used to control urinary tract infections. It controls the growth of bacteria. And so, it is another interesting byproduct. If somebody wants to use this, you can control the formaldehyde as well as make another interesting product. So, this also has been suggested as one of the ways to control. Then there are other compounds which are non-nitrogenous, right, non-nitrogenous compounds. Some of them are called the alcohol compounds, which are also used as scavengers. Ethylene glycol, I am sure you are quite familiar with this compound. Where is it used? Where is it used? It is used in the manufacture of polyethylene terephthalate, right. It is one of the monomers which is used for preparation, manufacture, synthesis of polyester, right. But here we are looking at this from a different perspective. What is ethylene glycol, you remember? Okay. So, this interesting compound, let us see. Then another compound which is the derivative of this compound called the diethylene glycol. So, two glycol molecules would make this compound. Interesting compound. So, it is a hydroxy compound again, alcoholic compound. Another compound which has been suggested for this purpose could be glycerol. Glycerol, you know, is like this. It is an interesting compound again. What are we aiming at? We are aiming that hydroxyl groups available can react with also formaldehyde at certain conditions, and the conditions could be curing conditions, the hot conditions that we actually use. If we are going for a simultaneously padding and drying curing, then you can add in a pad bath or as an after treatment, whatever you want, you can do that. Another compound which has been suggested is sorbitol, which is a 6 carbon compound. So, you have hydroxyl group of course on both sides, but also on other carbons as well. So, I have 6 hydroxyl groups available for binding a formaldehyde compound. Interesting, more the merrier. How will these compound react? Well, cellulose also had a hydroxyl group. So, hydroxyl group obviously can react. So, there is no doubt about that, isn't it? So, we would be able to work around, and this reaction, let us say with some alcohol like this, we represent this ROH plus formaldehyde can give, through an addition reaction, a compound which will be like this. Interesting. So, you are producing another compound which is binding an alcohol. So, the only thing is it can be done at a much more simpler, easier conditions, because these groups are available as molecules which can be anywhere wherever formaldehyde is required, and statistically possibly some reactions like this can be done. It is definitely an interesting proposition, and we would be able to therefore control the release of these groups as well. Similarly, reactions can take place with the other hydroxyl groups available, which could be another CS2OH group which can also react. Similar to these compounds, phenolic compounds have been suggested. One of the interesting compound that you have is known as resorcinol, right, resorcinol, and this compound is also in some sense is similar to what we have seen, and theoretically can make methanol resorcinol, which would be, let us say, the same compound after some reaction can add, let us say, this has been suggested. Therefore, nitrogenous, non-nitrogenous compounds have been suggested which can be used to control the release of formaldehyde. They can be used in the pad bath or as an after treatment, one will have to be being selective. One should be selective on what kind of process that you want to use. Theoretically, this compound which has been formed can also react to make either an ether link or a methylene link. So, I would like you to do this yourself in your notebooks. I do not have to write it down, almost similar to what we did previously with urea. So, when we talk about application, of course, you can apply through a pad dry process, padding process. You want, even if you are giving after treatment, you can pad through scavenger solutions and then dry and cure if it is required. That is a padding process. So, we are quite familiar with it. But people have said to avoid excessive use of water and excessive use of drying, therefore reducing the energy required through this process, people have used foam. You must have heard of foam finishing. If not, we will talk about it sometimes. That is, what is a foam? Foam is some liquid and air which has been injected into it, and you have bubbles. And bubbles means a large amount of volume of this bubble is air. The skin of the bubble is basically made of liquid, which contains the scavenger also, and of course, some water. So, in some sense, what are we doing is, instead of diluting, making a dilute solution with adding more and more water, you are diluting this solution by adding more and more air. Advantage you can appreciate that once the foam is applied, which can be applied by any method that you can think of, you can coat it, there are coating methods, and you break the foam by any method like passing through a nip. For example, there is a nip roll, the fabric is passing through this nip roll. Here, let us say you had created some applicator which can apply foam. So, the foam which contains the scavenger is being applied and it get broken here, and then you have less wet fabric moving out. Obviously, if suppose 80% is air or 90% is air, then the water is very less. So, your energy required to dry will be less, use and consumption of water will be less, and mostly it will be scavengers. So, therefore, from energy point of view, people have suggested that you can use foam. Well, whether you use a pad, dry, foam and cure, which is okay, or you can use pad, dry, cure, foam and dry. So, whichever process one wants to use in his own wisdom can be used, but definitely this looks like a very interesting proposition from the application point of view. Compare it with, let us say, padding, where a lot of water will have to be also used. You understand, you remember that wet expression? Yeah. Interesting. Fog chamber, that is, you create fog, mist, and if possible, let us say, while you are curing, if there is a free formaldehyde, it is going to go where? It is going to go in the air as a vapor. If in this situation you introduce fog or a mist by atomization process, okay, then both are in some sense in the vapor, in the environment of the chamber or a stentor or whatever you are using, and they react in the vapor form. And then in the vapor form itself, they can be extracted also, and then of course treated very nicely, like you have a scrubber through which this exhaust can pass, and then you can remove these compounds. All right, this becomes a very interesting way to treat. So, fog chamber is another application system where the scavenger is also in some sense in a vapor form, and the formaldehyde also will be in a vapor form, and reaction takes place in the vapor form. In the fog chamber, urea itself has been used. Again, interesting way to apply. And these things can happen almost as you are going through a padding, drying and curing process. Okay. Reaction can take place. So, let us say what have we done today? We have understood that if you can use formaldehyde free cross linking agents, obviously there is nothing like it, it is the best solution, we do not have to worry about it. But a good number of agents which are formaldehyde based agents are effective cross linking agents, and for them we would like to work on the controlled release, and therefore they can be various methods. One of the method of course is the afterwash, which we decided that at least for free formaldehyde it is a good idea, or scavengers which can be used in the pad bath, or it can be used as an after treatment, whether urea, ethylene urea etc., they can be reacted, carbohydrazate, ammonia, glycols, other polyols as well as various phenolic compounds can be used as scavengers. And also we learned that you can of course apply these by padding process, you can apply them through a foam based system, or in a vapor phase system these scavengers can be applied effectively. Finally, obviously to reduce the release of formaldehyde in the environment. So, we stop here, and in the next lecture we will take up another finishing process. Till now we have been talking about cross linking agents, anti-crease or crease resistant finishing process, and now we will take up a next finishing process which is stiffening process. So, stiff finishing, whichever we look at it. See you next time. Thank you.